the sections, same question paper. Okay, there won't be any different question paper. And so this is basically in section 2. This is the flow that I have planned for you. Okay. So before this, actually, let me also tell you that two books, at least two books, will be very much helpful for you. One is the Data Communications and Networking. Please write it down because I do not have a slide for this. I would request you, all of you, to please write down the name of the book. The one is Data Communications and Networking, 5th edition by Faruzan. All of you, please write down Data Communications and Networking is the name of the book, the title of the book, and the author is Faruzan. And just a minute, I think some others are also trying to. Yeah, somebody has started the recording. By the way, somebody is recording. May I know who is recording? So, Shashwat Shukla.
Yes.
Yeah. So, couple of protocols. I in general I do not mind recording, but it's a protocol that So, unless and until you take permission from the host, you should not be recording. Okay.
Okay.
So don't just start without permission. Okay. What I will do is yeah. Okay. So fine. Today you have started the recording, which is fine. And other classes, actually, one of our TAs, I'm going to request Ria or Chandrani, if you are here, please take care of the recording part, right? So let us just follow the protocols. Let us be a little decent and follow the usual conventions. Yeah, so I hope that all of you have written the title of the book, Data Communications and Networking, 5th edition. The publisher is McGraw-Hill, okay, MGH, McGraw-Hill, and the author of the book is Faruzan, F-O-R-O-U-Z-A-N. F-O-R-O-U-Z-A-N. So this is the main book that I am going to follow. Along with this book, from time to time, other books also I'm going to refer to. So for example, another book, Data Communications by William Stallings. Okay. Data Communications by William Stallings. Stallings is S-T-A-L-L-I-N-G-S, Stallings. Please write it down. By the way, that's the main book that will be covered in section 1. And whereas I am going to cover from Faruzan mainly, of course, so we are both going to look at other books also from time to time. Okay. So now let me go back and show you what I was trying to show. So lecture 1 is going to be the brief. That means lecture 1 means today, right? So today, the first hour, what we have planned is the brief history of networking and internet, need for protocols, and the objective of the protocols. Then we'll talk about the organization of the course in a little bit more detail and the outline. Okay. And then the second part of the course today is going to be on network topology and switching techniques. Okay. And lecture 3 is going to be on analog and digital transmission, pros and cons of analog and digital transmission, attenuation, delay distortion, noise, signal to noise ratio, then channel capacity, data rate, baud rate, Nyquist sampling theorem, Nyquist bandwidth, Shannon capacity. So these are some of the very important topics which particularly pertain to something called the physical layer. Okay, so these layering concepts, etc., you will learn in the course. So these pertain to something called the physical layer, and We are going to learn, but we are going to be very brief, because in this course actually our focus is on the higher layers. Okay, so what are these higher layers that also you do not know yet? I'm going to tell you later on. Okay, so this is going to be the lecture 3, but here actually we are going to be very brief, because the physical layer conventionally is taught in more detail in data communication courses in electronics and communication department. So basically your friends who are from the ECE, their focus is on these topics, right? They do not learn much of the higher layers as we will be doing. But in computer science department, our focus is going to be on the higher layers. And very briefly, we are going to cover, these basics of data communication. Then lecture 4 is going to be on the transmission medium. Here we are going to learn about what are the different types of media, what are the different types of different types of cabling, and what sorts of cables are required for connecting different computers, and particularly with respect to optical fibers, what are the different types of optical fibers, and so on. So these sort of things we are going to have a brief overview in lecture 4. Lecture 5 is this is by the way, this is still data communications part, physical layer, and so we'll be a little brief, but we are going to cover these topics so that you have a global view of how things work. Basically, this is going to be my goal, right? So I'm going to teach you how to basically internet work different computers, and also, like, we'll start from very basic, like, how two computers connect, right? So we'll start from there, then we'll keep on adding computers and how that sort of internet working is going to happen. So we are going to start small with two computers connecting, and then we'll gradually build up by adding more computers. Okay. So by the way, when I say computers, nowadays it is much more broad. It's not just computers, but most of the computing devices basically which can connect to the internet, right? So we are going to talk about those. But remember over here that if you talk about the internet, it is much more broad. There are so many things that are in there, and we cannot really cover everything that is out there in the internet in a one semester course. It will take a couple of semesters to actually cover everything that is there. But here actually our goal is to make you understand this much that will be helpful for whatever I said, like, building a small computer network, right? So, and trying to understand. Build means, remember one thing, so here you should not get misguided. So here actually when I say that building an internet, so we are talking about the theory, right? So of course we have a lab component, but as you will see during the labs, that the way the labs have been designed is slightly different, right? So there the focus is, because you are from the computer science department, there the focus is how to do network programming, right? So it is more programming centric over there. But here in the theory, we'll do a little bit of the concepts that are required for network programming, but here it will be more on understanding the concepts overall. So lecture 5 is going to be even further. There is something called error control, flow control, encoding, decoding, and so on. So you'll learn these things. Lecture 6 will still continue with different types of keying techniques for encoding, digital data with analog signals and so on. Error control, error detection techniques will continue. Lecture 7 is going to be on something called, few protocols are very important for the data link layer. So we are going to talk about those. And likewise, actually, I'm not going through all these terminologies because unnecessarily we are taking too much of time, and you will not understand really, all these jargons that I name over here. So lecture 8, then lecture 9 will be on something called MAC protocols, right? So there are different MAC protocols. We are going to learn what these MAC protocols are and how they work. So this is a very important topic, by the way. This is a very important topic, and you really need to understand. So this is from this lecture 9 onwards. This is where the higher layers that I was talking about, these are going to start from here onwards, right? So lecture 9, lecture 10, so in between you are going to have one test, right? So roughly it is going to be placed between lecture 10 and lecture 11. And then we will start something called the OSI and TCP/IP layers, right? So this is a very important and fundamentally important concept, layering abstraction, etc. And we are going to learn these things from there onwards, right? So lecture 12 is going to be a continuation of how some of the concepts that we are going to cover today itself. How to build the Ethernet, what is the origin of the Ethernet, etc. Lecture 13, likewise, lecture 13 will continue. Lecture 14, lecture 15, we are going to talk about something called the network layer, right? So network layer has certain functions. We are going to talk about those functions of the network layer. Lecture 16 is going to be on a few other protocols belonging to the network layer. Then lecture 17 is also going to be on network layer, something called routing. We are going to understand routing. Lecture 18 and 19 is going to continue those. So like that, actually, it's going to continue. Then we are going to have one more test. And lecture 21 is going to be on another very important topic, which is called the transport layer. So you might have heard about TCP, right? You might have heard about TCP protocol, UDP protocol. These actually belong to something called the transport layer. So we are going to, in the lecture 21, 22, 23, and 24, right? So, or even like 25, right? So we are going to cover the transport layer in detail. So transport layer, we need to really understand in detail. Likewise, the network layer also we need to understand in detail. And a little bit in somewhat detail, we will be understanding the layer 2, which is called the data link layer. So these layering terms also you might not be familiar with, and so you are going to learn them as we proceed down the semester. So we are going to have another test between 26 and 27, and 27 onwards we are going to start something called the application layer. Okay, so application layer we are going to cover in the next subsequent lectures, and yeah, and little bit if we find time, I have planned for now, but if we find time, we are going to do a little bit of something called the security, computer and network security, right? So we have kept it towards the end. Remember that in our department we have separate courses on security, and here actually our focus, if we can touch security as per the plan, here our focus is going to be on the network security, right? So this is something that I have kept towards the end. And finally, you are going to have the third test, which is going to be on the entire syllabus. Okay, the full test. So broadly, we are going to have couple of tests. So we have one test here. Here also you have a full test. So number 2, 3, 4, 5, 6. Okay, so this is the overall plan. But let us see, how much we can do, because it also depends on the availability of time and so on and so forth. So this is the overall plan for now. But remember that things are subject to change. So let me now close this and go back to our PPT. And here I have to reshare. So any questions so far? Anyone has any question? So remember that this is going to be a fun semester, and one of you please confirm that I'm still audible, because I never know, if I'm getting disconnected or not. So one of you please confirm again that I'm
Yes,
still audible.
sir.
Yeah, okay, that's good. If you do not have any question for now, so I'm going to proceed further, and I'm going to cover gradually. I'm going to start the coverage of some of the basic stuff, the introductory stuff of computer networks. Yeah, so what we'll do is I'm going to be back in a minute, and just give me a minute. So if you also want to take a break, so within a minute you can come back too. Okay, so I am back, and I hope that those of you who took a small break, you are back too. Yeah. So once again, a small confirmation that I am audible to you.
Yes, sir.
Okay, thank you. So time to time, actually, these confirmations are required because there is no other way for me. Because once I go to the full screen mode, there is no other way for me to really understand that whether I'm connected or not. Okay, so let us get started with first uh, the first introduction about computer networks. So yeah, let us first try to understand, right? So some of these are quite intuitive, and let us try to understand that how two computers, how they are going to communicate with one another, with each other, right? So typically what you are going to have is one computer and another computer, and there is some medium through which these two computers could be connected. And this medium, conventionally, you can assume that it's kind of some specialized cable which runs from one computer to the other. And basically, this acts as something called the medium, right? Through which the signals are going to be sent from the sender to the receiver. Okay. So one of these computers is going to act as a sender, the other is going to act as a receiver. And so the sender, basically, as this name suggests, that it is going to send the signals, and the receiver is going to receive the signals, right? So this is basically how a very small computer network is going to look like. So what do we have? We have a shared medium, which can be a cable, a wire running between the two computers, as I said, or it can be a completely wireless medium, as we mostly experience nowadays, that most of the devices nowadays, most of the computers are connected wirelessly. And so in such a case, basically the medium is the wireless medium, the air becomes the medium, right? So actually air doesn't need to be the medium. Like, nowadays, for example, one of my areas of research is something called underwater networks, right? So underwater communication, they are actually, water is the medium, air is not the medium, but water is the medium. Okay, so like that, actually the medium can be varied, right? So there are different types of media through which the signals can propagate, right? Now the question is that for different medium, you need to have different set of uh, you know signaling techniques. You need to have completely different type of hardware, and you also need to have something called protocols. Protocol is something that you are going to hear quite often. So these protocols are basically the rules, right? So these different types of rules are going to be there. So these rules basically, these rules are basically, the ones that have been designed in such a way that there are different um, steps that are going to be involved for this particular unitary communication. And so these steps are going to be governed by these rules, right? So these rules in computer networks are going to be termed as protocols, right? So you will often hear different types of protocols. And here in this course, actually, we are going to learn some of the very important protocols that help in this kind of communication between a sender and a receiver. Now, in this particular figure, what you see is a single sender and a single receiver, but basically, you can scale it up. You can have multiple senders, multiple receivers, different types of topologies, uh, and so on and so forth. But that's going to complicate stuff, right? So for now, we'll start with a single sender, single receiver. But remember one thing, that in this particular figure, what is shown is that the message basically goes from this computer, the left-hand side computer, to the right-hand side computer, right? But communication can also be duplex, right? So which means that the messages can also travel from this end to the other end, right? So both ways actually communication can also happen. But for this actually you need more sophisticated stuff. Sophisticated algorithms are there, and some of these are such that a lot of research, full duplex communication is something that is there, so far actually mostly what used to happen is something called half duplex communication. But full duplex communication is basically a matter of research right now. A lot of research works are going on full duplex communication. So anyways, we'll not get into full duplex, etc. So for now, we'll just go with the basics so as not to complicate the stuff, right? So so what is very important? So you have one sender device, you have a receiver device, and they need to communicate. So so communicate means like so what's going to happen is signals are going to be sent from one end to the other, which can be translated into a stream of zeros and ones, which are going to be sent essentially, right? So series of zeros and ones. So these zeros and ones basically are going to have the information encoded in them, so that the receiver basically can decode those zeros and ones, and they can understand what the sender has sent, right? So so what are the very important things that will have to be kept in mind? You will have to, number one, you will have to ensure that there is successful delivery from the sender to the receiver. Successful means like if a sender has sent some unit of data, right, which let us call as a message, right? So if the sender has sent a message, then you have to ensure that it is successfully delivered to the receiver. Because this is one very important important factor that basically governs the performance of a computer network, right? Successful delivery. So a message which is basically sent from the sender, successfully received by the receiver, right? So successful delivery of the message. This is one very fundamental characteristic which decides the performance of a computer network. So there are different reasons why the message may not be delivered, right? It's ultimately some medium, and due to the medium, different things can happen. So there might be some noise, or there might be something, because of which the message may be completely scrapped in between. It might be dropped, it might be corrupted. Many things can happen, right? So successful delivery of the message is one such parameter which decides this computer network. Second is accuracy, and this decides the performance of the computer network. The second fundamental characteristic is the accuracy. So accuracy means so if the message is sent from the sender, whether it gets accurately received by the receiver, or whether it has been tampered with, or whether it has been corrupted, right? So accurate. So whatever you send, whatever message is sent, whether it is accurately received at the receiver. So this is the second parameter. The third parameter is timeliness. So how fast the message is going to be received at the receiver. How fast. So whether there is going to be some delay, how much delay. So of course there will be some delay for sure due to the nature of the medium, but how fast you can deliver the message, how far the medium can deliver the message, right? So that is called timeliness. So there is a parameter which is called delay or latency, which basically dictates this particular performance characteristic of a computer network. And the fourth very important parameter is called the jitter. Okay, so jitter is basically how much what is the change in the delay over time. Okay, so the change in the delay over time. So that means that, let us say that so there are messages, right? So one message, second message, third message, etc., which are, let us say, sent periodically, right, at constant intervals of time. And now that message, all these messages, let us assume these are passing through the same medium, right? So the first packet, let us say, first message takes, let us say 30 seconds, 30 milliseconds. Yeah? So let us say that it takes 30 milliseconds. The next one also takes, let us say 30 milliseconds. The next one after that, maybe it takes 40 milliseconds. The next one, maybe it takes 20 milliseconds. The next one takes 50 milliseconds, right? So the time rate of the time with respect to time, the change in the delay, right? The change in the delay, that's a parameter which also is very important to understand the performance of a computer network, right? So that is called, technically it is called jitter, and the timeliness is governed by the technical term of it is called latency, or sometimes people also prefer to call it as the delay. So we'll try to understand this delay and jitter in more detail as we go along in this particular course. We'll be encountering these terms more often, and at that time mathematically I will show you how to basically compute these different parameters. Okay, any questions so far? Okay, now, so in the previous slide, what I had shown you were two computers connected to each other. Now, it might so happen that there might be multiple computers. So in real world, you will rarely have a scenario where one computer is connected to another computer only. So the scenario that is more typical looks like this, right? So you have several computers like the ones or printers which are connected to the internet, connected to the network, which will have to communicate with one another. Now you see that the life has become much more complicated over here. So here it is not a single stream of messages that are flowing across between a pair of nodes. So here actually we have several devices, several nodes as these are called, which will be taking part in the communication. So one of the complications that comes, there are several complications that will come in if you think a little bit deeper. One of the complications that come in is that so many of them are there. So how do you govern, like which message, which of these devices, which of these computers or the printer, which of these is going to first transmit the message? Because everybody has some message to transmit, right? So how do you decide which computer is going to first send the message across? How do you decide that, right? So for that, actually, there are so many different protocols that have been designed. Some of these protocols which help to have this kind of discipline are basically meant for wired networks, and some of them have been designed exclusively for wireless networks for reasons that we will understand later on. For now, let us try to just understand that scaling up is not easy, right? Scaling up is not easy. There are so many issues that will come into picture, like the one that I just mentioned. So you have a network of devices, you have a set of computers which are interconnected, and these computers are typically called as the nodes. Actually, this is a more broad term. A node is a more broad term. So these can be like computers or printers, or these could be different other devices that are internetworked or connected to the computer, connected to the network. So we'll use these terms like devices, nodes, etc. Interchangeably, right? So basically, so this is how the computer network is built. Now, then what do you have? You have different network criteria that you will have to consider. Performance, like whatever I mentioned earlier, right? So whether the packets come on time, how much is the time variation of the delay in the arrival of the packets. Then there are many other things like through the single channel, how fast for example per second, how many bits are going to be transmitted, right? How many bits are going to be transmitted. So like this, actually, there are so many different other important performance criteria that are there, which will basically have to be taken into account in order to understand whether a certain protocol or a set of protocols which help in the functioning of the computer network, how those protocols they perform, and the network as a whole, how it performs. Reliability is a very important factor, because ultimately, if you have packets which are going to be tampered, which are going to be corrupted, which are going to be dropped, so this kind of network is going to be of no use, right? You need networks which where reliability is very important. Reliability of packet transmission, reliability of message transmission is very important. Security is a very important factor, although, as I said before, when we were discussing the course outline, that security is something that we will try to touch upon towards the end of the course, but depending on the time. But security is something that is focused in multiple courses in our department. So if you are interested on security, please feel free to take those courses. So security is very important. So you have to ensure that security means what? So you have to ensure that the network is basically accessed by only the intended users, right? Only the intended users, and the packets basically that are sent across between the nodes, these are not tampered with, right? These are not changed, or nobody gets access, unnecessary access or unintended access to the packets that flow all across. So sometimes you might be hearing me talking about packets. Packets is a very technical term in computer networks, and sometimes I am using it superfluously, but it has its own specific connotation. Generally, so right now when I'm talking about packets, I simply mean like some messages, right? So I do not mean necessarily. I do not mean the specific specific meaning that is there in computer networks for the term packets. Okay, so this is what happens in a more realistically occurring computer network. So basically, so with this, basically, many of these, these networks are basically the kind of backbone, the skeleton that governs something called cluster computing. You might have heard about something called cluster computing, right? So cluster of nodes basically taking part in high performance computing, cluster computing, grid computing, and even nowadays people are talking about cloud computing. So all of these, basically the network is very important. So interconnectivity of the computers is very important. Otherwise, all of these concepts like cluster, grid, or the cloud computing, all of these concepts are going to basically fall apart, right? So these are not going to work. Let's proceed further. So let us try to understand now that how does the network look like, right? So how do you build the network? So what is the physical structure of the network? So the physical structure of the network basically depends on the type of connection and the physical topology. So what is this type of connection? Let us try to understand the type of connection. So so when we talk about computer networks, just think that what sort of connections are possible. If you have multiple computers, or maybe to start with the first figure that I had shown, we have two computers. So you can have something called point-to-point connection. Point-to-point connection means like you have a single transmitter and a single receiver, and the messages are directed from one computer to the other. Single transmitter, single receiver, point-to-point connection. Now you can basically extend this type of connection mechanism to also include multiple recipients, and that is called multi-point, or sometimes it is also referred to as multi-drop. So multi-point connection is where multiple recipients basically share the transmission medium, right? So basically you have so you have a single, for example, you have a single transmitter and you have multiple receivers. You have a single transmitter, you have multiple receivers. So these multiple receivers are going to continuously receive the streams of messages that are going to be sent across by the transmitter, and that is called multi-point connection. So multiple recipients of the single transmission. So, okay, so in the point-to-point connection mechanism, you have only a single receiver for the single transmission by the transmitter. Okay, now so we now understand the two types of connections that are going to be used across to build the network. Now let us try to understand that what are the using these connections, what are the different types of formations, what are the different types of something called topologies that are going to be built for the computer network. Topology means like the different types of forms, the structure, the architecture of the network, right? So now what we have is we have several computers that are going to be there. So how you are going to connect these computers, in what fashion you are going to connect them, this is very important. So this is basically this defines these different types of topologies. So we'll talk about these different types of topologies today also briefly, and later on in another lecture we are going to discuss them in even further detail. So we are going to talk about these topologies shortly, but what is also important to understand at this point is that in each of these topologies there are different types of transmissions that are quite usable. These are common. One is called unicast, the second is called multicast, and the third one is called broadcast. So unicast means like so you have one transmitter which wants to send some message to a single receiver, so you have unicasting. So so from one to another. Then you have the multicast, where there are a group of receivers that are predetermined somehow, so somehow there is something called multicasting or multicast group formation. Through these multicast group formations you have multicast groups. So basically the transmitter basically keeps on sending whatever it wants to transmit to these groups of receivers in the multicast group, and all of them, they are going to receive these transmitted messages. And then you have something called broadcasting. Broadcasting is that it is not a set of receivers, it is not simply a finite set of receivers, but all the nodes, all the devices, all the computers in the network, they are all going to get a copy of the message that is sent by the transmitter. So you have unicasting, multicasting, and broadcasting. So remember, I told you that we are going to cover something called the network layer. And when we cover network layer, we are going to talk about something called routing. And it is at that point I'm going to elaborate further what are these different types of unicast, multicast, and broadcast mechanisms that are there, which can be used to transmit packets in the manner that I mentioned for transmission. Okay, so let's go ahead further. So let us try to understand the type of connection. So we have the first one. Look at this particular figure, right? So you have a dedicated link between two computers, two devices, two nodes, two stations. So all these terms, nodes, devices, stations, basically refer to the same thing, right? So this is basically the point-to-point connection. You have a dedicated point-to-point, point-to-point link between these stations. Now, this is good. This is good to start with, because here actually what is going to happen is because it's a dedicated link between only two stations. The entire capacity of this link, the entire capacity of the link is going to be reserved for transmission between this station and this station. So entire resources, entire bandwidth, is going to be dedicated for the transmission between these two stations. Nobody else is going to have a share. over here because it's point-to-point. Sometimes point-to-point connections are very important, right? Point-to-point connections. Now, multi-point, also as I said before, multi-drop is something like this. The second figure, something like this. You have one computer and you have a link which is basically shared by multiple stations. Okay, so this single link is no longer shared by only one station, but more stations also share this link. So then you have something called multi-point connection, or why these are called multi-drop, because these stations basically, as you can see, kind of like they drop on the main shared link. So this is why these are also called multi-drop. So multi-point or multi-drop connection is the one in which more than two specific devices share a single link, as I just showed you. Okay. Now, what is different between this point-to-point and multi-point? So basically, in point-to-point, as I said before, you have all the resources shared only exclusively by two stations, these two stations. Nobody else is going to have a share of the resources. However, in this kind of mechanism, multiple stations are there who are going to share the resources. So share the bandwidth, for example, right? Share the resources that are available through this link. The capacity of the channel is shared. So how this sharing is going to happen? Either they are going to happen spatially or temporally. So spatially means like there is a fixed, spatial configuration through which, it is dictated like, who is going to have share of the capacity, or more in a more advanced manner, so temporally. So sometimes, let us say, very quickly things are going to rotate, but sometimes station 1 is going to have the share of the resources. The next maybe immediate next moment station 2, station 3, like that. So time varying, right? So time varying sharing of the resources can happen, or spatially varying. So spatially means like it is already dedicated, like which station gets access to the resources and so on, right? So so this is basically the two types of connections, point-to-point and multi-point. So any questions so far? I hope that everybody is with me. If I have lost someone, please let me know. And try to listen to me, because the way I'm trying to present is so that most of your preparation happens in the class itself. If you listen to me very carefully, I am trying to present the things in a more story-like fashion, so that if you simply listen to the stories, you get everything drilled into your brains, right? So please make sure that you listen to me very carefully and do not get lost. If you want me to repeat something, do let me know. Now, let us try to understand a little bit more sophisticated mechanism. So what I had shown you earlier were very simple, networks, how the different computers are going to connect. But in practice, things are a little bit more sophisticated, right? So let us talk about a more sophisticated scenario. So let us say that you have one department which is networked, the computers in which are networked through something called the local area network. Let us say that this is the local area network of the computer science department. So here, as you can see, they all form something called the local area network, or in short, you might have heard this term, the LAN, right? So this is the LAN, so one LAN. Likewise, there are different other LANs that may also be formed. So here, actually, as you can see over here, this is one way in which the LAN can be configured, right? So this is something called, which I will tell you later, but this is in advance, I'm just telling you, this is something called the bus topology. And over here, exactly the same thing we have done, multiple computers forming a LAN, local area network. they are all interconnected, but through a different topology, which is called the star topology. Okay, so these topologies you will try to understand more in detail shortly, but and we'll dig into these when we talk more of the network layer. But for now, it is sufficient to understand that these networks, these computers, these could be connected in different ways. This is one way in which they can be connected. We have a dedicated shared link, which is basically accessed by all these computers over here. And here actually it is different. There is a separate device which is called the hub device, which basically controls all these access, right? So basically, if computer A wants to send some packet to computer B, then it has to go through the hub, right? So it's like this. Actually, these are not the only two. There are different other topologies that could also be used in order to build the local area network. So let us say that you have one department, you have another department, and then these departments, or let us make let us take a different example, because I will tell you a little later that how you form the LAN and what is the scope of the LAN, what is the scope of something called WAN, etc. These could be varying. So for now, let us assume that this is the local area network of entire institute, entire IIT Kharagpur. And this is maybe some other institute, let us say another university, Jadavpur University, let us say. So we have two different local area networks, right? Now you see that there is something over here which is called the wide area network, right? WAN, in short, it is called the wide area network. So the scope of wide area network is little bigger than the local area network. So you have you have multiple LANs which finally are going to be connected in certain way, etc. And finally, so they are again going to be connected somewhere to some other service provider or some some different network, right? So maybe at the national level or something like that. So you see that in between how these connections are made. So this is very important to understand. So you see that you have something called a router, and router is a term I'm sure that most of you have already heard about, although you may not be understanding fully what a router does. And by the end of this course, you will really understand what is this router and what are the functions of the router. So you have a router which acts kind of like the external gateway to this LAN. It is kind of a gateway. The gateway means like it's going to be like going outside this particular LAN, right? So you have a router. Likewise, you have another router, okay, which connects to this wide area network. So you have a local area network, you have a wide area network, and you have kind of like two gateway devices which are called routers. And you can have point-to-point link between these two routers, point-to-point. So what I said before, so the advantage of point-to-point link is that all the resources are dedicated between these two routers, right? So because it's point to point, nobody is going to have a share of the resources. So you can have a very high performing link running between these two routers, right? And that is required, right? So it is required because ultimately between these two gateways, you need a high performing dedicated link, right? So that is where this point-to-point mechanism might be helpful. It doesn't need to be point-to-point, but so this is the advantage. In this particular example, it is shown as point-to-point, and the advantages of point-to-point is understood. So likewise, so here it was this LAN which was connected to this particular gateway device, the router. And here also you have another similar gateway device to which this particular router is connected. So you have point-to-point WAN. So here, remember that I am using these terms like hub, router, gateway, interchangeably. But remember that they all have their specific scope and they are a little different, right? So again, what is the specific scope of these terms we are going to understand as we proceed along. So not today, but in a future lecture, you are going to understand the differences between these terms like gateway, router, hub, switch, etc. So now we are at the layer of the WAN, right? So we have the wide area network, and wide area network it spans across, like, a bigger geographic area, right? So you have maybe city scale or something like that. And so here, because the scale is much more broad, you need something called the switching mechanism in order to send the packets across in the wide area network. So this is the first time you are listening from me this term switching. So switching is something that we are going to dig further into as we proceed along. So switching, we need to understand what is this switching. So it is going to be a switched WAN, right? So what is this switching? We need to really understand, and what are the different mechanisms of switching? We need to really understand those as well. So you have one modem, you have another modem. Between those, you have the point-to-point wide area network, and finally it can go. So like this, so this sort of building up, connecting different LANs, WANs, and scaling it up further. So these are the things that you can do to basically scale the network further. And this is where basically this internet, the current internet that we are all using, which is globally spanned across, is basically, it is using these small smaller these topological concepts like the LAN, WAN, etc. So all of these, they so you will be able to find all across in the global internet, thousands and thousands of LANs, not thousands, millions basically now, right? Thousands and thousands of WANs and etc. But you see that how do you build this kind of internet? How do you build this kind of network, right? So we will try to understand, and when we will look into very shortly the history of the internet, there you will find that it all started very small. And gradually things became more sophisticated, more complicated. And this is where the more you become sophisticated, you make the internet work, or the computer network more sophisticated, you need more more sophisticated mechanisms to handle these complexities. So let us try to have a recap. So we can have different types of networks. Local area network, in short, these are called the LAN. And I'm sure that you have heard about this term, even if you do not know fully what is the meaning of it. So local area network basically are formed to connect computers in short distances. And so as this term suggests, that it is for local networking, local interconnectivity. Typically, you will not find local area networks beyond, like, only a couple of kilometers at most, right? So not even that, right? So campus scale will typically be an example, or department scale, campus scale. These are going to be an example of local area networks, how much it is going to span. So then wide area network, basically wide area network are for longer distances, right? Longer distance communication. Okay. So these basically provide connectivity over larger areas. So like city scale kind of thing, right? And there is a specific term which you can think of, like in the broad scale wide area network. This is called metropolitan area network. So this term is used specifically for providing connectivity over areas such as the city, metropolitan area, right? So metropolitan area network, right? So typically it is at the city scale, but even if you like have a big campus, right? And maybe campuses in a city spanning all across, there also you can have like metropolitan area networks. So let us try to understand this local area network in further detail. So local area network, this is on the right hand side, is what you would typically see in a local area network, right? So let us try to understand this, how it works. So typically, let us say IIT Kharagpur LAN. So when I say IIT Kharagpur LAN, all these computers belong to IIT Kharagpur, and so these are like all these computers belong to IIT Kharagpur. So these are like privately owned by IIT Kharagpur, right? All these computers, nobody else has share of these computers, right? So no other institute basically has share of these computers. So these belong exclusively to the network of IIT Kharagpur. So these are privately owned in that sense, and so there are links that basically connect these different computers in a certain way, right? So you can have different floors of a building, like this. All these computers are part of a certain floor, maybe another floor, like that. You can have, you can connect them, or maybe these computers belong to a certain department, these maybe belong to another department, like that. So you can have, these are actually privately owned and links their devices in a single office, a building, or campus, right? So there is no fixed thing like how much is going to be the scope, whether it is only for a specific building or a campus or so on. So this is typically like how it is done. So a LAN can be can start from connecting only two PCs, connecting a PC with a computer, or two PCs with a computer. It can start from this kind of configuration in a small office or from somebody's home, and it can extend, this concept of LAN can extend all the way up to, let us say, an organization level, right? And so these could also include like cameras or other audio peripherals, etc., to be part of so it's not necessarily that only computers and these computers and printers, but it could be other devices like audio devices, video devices, etc. So currently the LAN size is limited to only the few kilometers only, right? So typically it is of that range. Now, okay, metropolitan area network, as I said, is basically, so it is a little bigger. It's the size between a LAN and a WAN. And WAN, actually, I mean, WAN is much more wider. You can think of a MAN to be like a specific type of WAN as well. So it's the scope is a little bigger, so the dimensions are bigger. And so it normally covers the area inside a town or a city, and it is designed for customers who need a high-speed connectivity, normally to the internet, right? So high-speed connectivity can be provided using this MAN, or even like, as you will see shortly with a WAN as well. And they have endpoints that are spread over a city or a part of a city. So this one, basically, the example of a MAN is the part of the telephone company network that can provide high-speed DSL line to the customer. I do not know how many of you have seen the DSL lines, right? So the other day, actually, I was talking to one of my students who is now a faculty in IIT Guwahati. It seems that in IIT Guwahati, they still have these legacy DSL lines, right? So like that, actually, some other organizations might also be having these DSL lines, but in IIT Kharagpur, actually, we have much more, advanced networking technologies that are used, right? So provide, I mean, so when I say like, advanced, like, so I'm sure that other institutes, like, even if they are using DSL, they might be also having other sophisticated ones. So it's not that, but it's basically, in some places people are still continuing to use DSL, right? High-speed DSL line. So so this is the MAN, and then comes the WAN, right? So WAN is, you can start from city scale, you can go all the way, to connect like, multiple cities, or that kind of scale, right? You can connect, right? So a wide area network basically is used for longer distance transmission. So obviously you need much more bandwidth, you need much more kind of resources to be made available through the network. So these switched, so there can be two types of WANs. One is called the switched wide area network. The other one is the point-to-point. So point-to-point is quite simple to understand. So you have, so let us say that this is one LAN, this is another LAN, and between those you have point-to-point connectivity, right? So point-to-point advantages I told number of times today. So you have this link basically gives you high bandwidth, dedicated resources made available between these 2 points, right? So so these points basically point-to-point wide area network basically has leased lines from a telephone or cable TV provider, and that connects basically a home computer or a small LAN to a internet service provider, like over here, right? So you can have a home computer or a small office computer connected to the internet service provider, right? Point-to-point link. So the other one, which is called the switched LAN, is much more interesting, because here actually it is not point-to-point. So here you have multiple end systems, as you can see over here, right? So there has to be some mechanism by which all these different messages, the packets, etc., will have to be decided, like how they are going to be sent across, right? Because it is no longer going to be just one point to another point. You have multiple end systems, and between these end systems, how the packets that are going to come, how you are going to decide, like spatially or temporarily or a combination of both, how these packets are going to be sent. So this is where these switching devices, they basically help. Now, as you can see over here, in a WAN kind of scenario, you do not have a single switch, right? You have multiple switches which are also networked between them in a certain configuration, like the one that you see over here. In a certain configuration, these are also switched. Okay, now let's go a little forward. So let us try to understand. So internet is worldwide network of computers. So not only computers, but the computer network, small computer networks interconnected together forms the current day internet. And this internet basically, as I will tell you shortly, this has basically evolved over the years. It started small, it grew big, and it is so complex nowadays is that you need more sophisticated mechanisms to understand this complex network. So in our department, for example, there is a research group which works on something called complex networks, right? So the internet is an example of a complex network, right? So large scale networks, how you can build these kind of networks. To understand these networks, you need these complex network concepts. So how does it work? Most computers are not connected directly to the internet. They are connected to smaller smaller networks, which are connected through gateways to the internet backbone. And this is what I was showing you over here, right? Do you remember? So this is what I was showing you. You have small networks, local area networks, local area network. You have a wide area network. These local area networks connected to the wide area network. And like this, actually, you scale up, you build bottom up, you get the whole picture of the internet that way. You understand how the internet looks like. Now, let us try to understand the hierarchical organization of the internet, because this is something that will help you to understand many of the concepts that we are going to talk about later on. So at the national level, you have a national level ISP. ISP means Internet Service Provider. This is something that everybody knows by now. So you have a national level ISP, you have regional ISPs, you have several regional ISPs in a particular country, and then you have more like specific ISPs of which are there, right? So you can have, for example, national ISP could be BSNL, for example, right? And over here you can have more like BSNL basically leases certain lines to more localized private ISPs, etc. Then you have these small either regional ISPs or more localized ISPs. So this is basically the structure of the national ISP. So you see that within this national ISP, under this national ISP, you have regional ISPs, and within these regional ISPs, you have more of these ISPs, right? So this is how this is kind of a tree-like structure, right? Inverted tree-like structure, or even you can invert the other way also. It is going to be the same thing. So it's going to be a tree-like structure, right? And now you see that how these national ISPs are connected. So national ISP, another national ISP, another national ISP. So all of these could also be connected, and they can also form another, switching network kind of thing, right? So they in turn. So now you try to understand, you try to imagine that how sophisticated this global internet is, right? And within the jurisdiction of a national ISP, you have regional ISP. Within the jurisdiction of a regional ISP, you have more localized ISPs and so on. So again, these national ISPs are connected together at the international scale between countries. Try to understand that what is the complexity that is going to be there, right? Highly complex. So this is what I was telling you, that the internet is a complex network. Let us now try to understand. We have understood broadly how the internet basically looks like. Let us now quickly try to understand who made this internet, how this internet came into being, and what are the different important concepts in the history of the internet. So if you look at the internet, right, late 1950s or early 1960s, there used to be this organization which is called the ARPA, A-R-P-A. Okay, so this ARPA is basically an US agency, Advanced Research, what is the full form? Advanced Research Projects Agency. Advanced Research Projects Agency. ARPA is the one which basically can be thought of to be the ancestor of the current day internet. So ARPA, which was responsible for forming something called the ARPANET those days, right? So remember that when we are talking about 1960s and so on, so it was still the time of the Cold War, right? So it was the time of the Cold War, and US always invests a lot of money for defense. So US particularly, in those days, like around the 1950s, etc. Mainframe computers used to be standalone computers, right? So these are like big computers which can do a lot of processing, batch processing, for example. But these are standalone in a particular place. These are there, they cannot talk to one another. So everything. So there was a requirement, like Department of Defense, there was a requirement that how you can network these different computers or the mainframe devices, right? So this is where this ARPANET was formed. It was formed in the 1960s. ARPANET was formed. Then this ARPANET, the way it was formed was to act as a store and forward network. Store and forward network. So it is called datagram network. So what is this datagram? You do not know yet, but it was a datagram store and forward network. So what is this datagram network? I will tell you today itself if I can, otherwise next class. So store and forward. Store and forward means, like, when a computer in a network receives some messages, it stores for a little while. It can also process the information, partly or fully, and then it forwards to the next hop device, next hop node, right? So this is called the store and forward. Store briefly and forward, right? So this is where this ARPANET was formed in order to connect these big computers, the ARPANET computers. Now, so ARPANET basically was a huge success because it was the first time people talked about sending messages across different computers. It was the first time people were talking about it. So ARPANET conceptually became a huge success. And then basically it became popular. There was a lot of research that was going on, right? people already knew that so this ARPANET is possible, and 4 organizations participated in the in the formation of the ARPANET. One was the University of California, Los Angeles, UCLA. The other was UCSB, Santa Barbara. The third is the Stanford Research Institute, and the fourth is University of Utah. So 4 organizations basically became 4 nodes of the ARPANET in the 1960s. Okay. And then there was not only hardware, but also they came up with a software which is called the Network Control Protocol, NCP. Okay. So this Network Control Protocol was formed, okay, to connect. So going back a bit, so ARPANET was there, but there was a scientist by the name of Kleinrock. You will hear this term, this name quite often, because you can think of like he is one of the pioneers of the modern day internet, Leonhard Kleinrock. In 1961, he belonged to MIT, had shown the concept, he had demonstrated the concept of something called packet switching. Okay, so packet switching for bursty traffic. Bursty traffic means that it's not a continuous traffic, it comes in bursts, right? So in bursts, basically in bursts the traffic comes, the data comes. So for bursty traffic, Kleinrock in 1961, he had shown the concept of demonstrated the concept of packet switching. So for now, just remember packet switching, but I will talk about packet switching in much more detail later on. In the 1970s, this concept, this work of Kleinrock, this concept of ARPANET, this connectivity and the demonstration of connectivity between these 4 nodes in the Northern California. So these concepts basically was taken even further. Okay. So 1970s, 2 more scientists, Vint Cerf, again another very important name to remember, Vint Cerf and Bob Kahn, right? They basically they extended it further, and they came up with a very important research paper in the early 1970s, around 1973, 1974, around that time, to demonstrate the internet working through the project that they called as the Interneting Project. So Interneting Project was kind of like the internet working kind of concept, demonstrating the internet working concept through the use of something called the TCP, Transmission Control Protocol. Okay, so by the way, over here it is there is a typo. It is not Transfer Control Protocol. It is Transmission Control Protocol. Okay, so I will change it. So Transmission Control Protocol. Basically, Kleinrock had come up with a paper to show the feasibility of transmission control protocol to work for datagram based bursty traffic, right, through packet switching network. Now, so along with TCP, another protocol also evolved in the 1970s through these works, which is called the IP, right? So this is where this TCP IP suite of protocols first came into being in the 1970s, in the late 1970s. Now, people were working, everything was fine. Then another institute, UC Berkeley, University of California at Berkeley, they came up with the Unix operating system around the 1980s, right? So the Unix operating system was there, but what they did in the 1980s was they modified the Unix operating system and included the TCP IP. Right? Which basically was kind of a contribution that came from the 1970s work of Vint Cerf and this Robert Kahn, and also the ARPANET people. And then basically this 1980s, basically into the Unix operating system, Berkeley Unix. Basically, this TCP/IP was made part of it, part of this operating system. Now, then things evolved even further. Because the origin of the internet itself is defense related, military related, another military network was formed, which is called the MILNET. MILNET was formed. So MILNET was formed exclusively for military users in the US, right? Military users, MILNET, military network. That was in the early 1980s. And basically this ARPANET was left alone for non-military users. Okay, so this is what happened. Now, using this concept, different organizations, for example, the Computer Science Network in the US again, they formed the CSNet, the NSF, the National Science Foundation Network. The NSF Net was formed. NSF Net, National Science Foundation, is basically a research organization in US. So they had their own network for the purpose of communicating different computers. So NSF Net and many other networks were formed. Now, another very important evolution was in the 1990s by another scientist, Tim Berners-Lee. This is something I am sure that many of you know as kind of a general knowledge, right? Tim Berners-Lee. So who can tell me what did Tim Berners-Lee do? Anyone? Quickly, don't search in the internet, okay? So then basically, so you are kind of cheating yourself, right? So please tell me, what was the invention of Tim Berners-Lee in the 1990s? Anyone? Am I still connected to you?
Sir, World Wide Web.
Very good. Your name?
Sir, Sayukta.
Yukta. Okay, very good. You are very right. So 1990s was the birth of the World Wide Web, right? So World Wide Web, you can think of, which was kind of an invention by Tim Berners-Lee, was basically where this commercial application of the internet for sharing data across, the way we enjoy that different information over the internet, the way we see it, the way we use it, that basically was invented by Tim Berners-Lee, right, for sharing information commercially or otherwise, also sharing the different data, right? So World Wide Web, as we all know, has a lot of rich content, right, spread across the internet, right? So a lot of data, a lot of information, all resources are made available, like all these YouTube resources, or Wikipedia and many other, so millions and millions of resources available through the World Wide Web. So this is from these late 1950s or early 1960s to 1990s. This is how the things have evolved, right? I hope that things are pretty clear to all of you, how things have evolved. So in short, basically, this internet has its origin in the ARPANET project in the US, which was sponsored by the US Department of Defense. Okay, let's move forward. So this is how the internet looks at present, right? Have a look. I'm not going to explain anything further, but this is basically, how complex it is. And I mean, this is even an abstraction of the complexities that are there, right? It's just an abstraction. But you can understand that there are thousands and thousands and thousands of service providers, each forming their own different network at the customer premises. Customer networks are formed, right? And then you have backbone networks. Several backbone networks are there. These backbones, they are even connected between themselves. They are again connected to the service providers, and like that, actually, this sophisticated complexity is there. It's a complex network. Complex network is a terminology, by the way, right? So it's a terminology that is used in computer networks, complex networks. So if you recall that I was telling you that protocols are used, right? So what is a protocol? So, and this is a term that you will be hearing very often. The dictionary meaning of this term protocol is rule, right? Rule means rule, right? So the rules, protocols means rules, right? So you will be often hearing this term protocol. Computer protocol, network protocols means these are certain rules which have been framed to make the computers work in a certain way, for them to communicate with one another in a certain way. So so these protocols, depending on which protocol you are talking about, they can help in diverse types of communications. So they can determine, what has to be communicated, how the communication is going to take place, when the communication is going to take place, and many more, right? So the more number of different protocols you go through, the better you will try to understand or appreciate the value of these protocols and the role that they play in the functioning of the networks. So in protocols, basically, you have three things. One is the syntax. Syntax means syntax. I don't need to explain what is the meaning of the syntax to you. Semantics, that also you know, all of you are computer science students, what is the meaning of semantics. And the timing. So these are the three very important things. So syntax, semantics, and timing are the key elements of any protocol. So in case you need to know a little bit further, so here is a slide that I have dedicated for this explanation, but I'm not going to do it, and I will leave it to you to understand. Now, what is the need of these protocols? So the setting up of the procedures for sending and receiving messages is required. So once you send a message, you can send it simply, best effort as it, so you just send the message, and you just wish that the message goes all across, right, all the way up to the intended receiver. Or sometimes you might need to get an acknowledgement of receipt. Okay, so whether the intended recipient has got or not, you need to be sure. Right? You get an acknowledgement of receipt, like the way the modern day couriers work, or even like in the speed post, in the postal system. Previously, so there was one way, like, you send an envelope in the postal mechanism, and you simply send it. If it reaches, it reaches. If it doesn't, it's a bad luck. So there used to be another one where you could also request an acknowledgement. You pay a little bit more money and you get an acknowledgement of receipt, right? And so how these things are going to be governed, whether you are going to get an acknowledgement or not, whether it is actually required to get an acknowledgement for a certain application or not. So these are many very sophisticated issues that are there. And if you try to understand all of them together, I'm sure that you are going to be lost. So what we'll have to do, you will have to take a gradual approach. We'll have to conquer this complexity bit by bit. Now, on top of that, you can have congestion. Now you can avoid the congestion from happening. So that means that multiple stations basically trying to send through the same bottleneck link at the same time, right? So there might be some congestion. You can avoid congestion. You can, if congestion has happened, you can control congestion. And error correction, right? So if there is some error, some packet has been lost, or some packet has been modified, or something like that, there are mechanisms by which you can detect the error, you can correct the error, and so on. So for this you need protocols, right? You need different set of algorithms, different set of rules which can help you to deal with all these complexities. You also need to have certain mechanisms to ensure that the source and the destination are basically properly addressed. And you also need to ensure the integrity and the security of communication. You need to ensure the integrity and security of communication. So like this, actually, there are many other issues that are there, due to which you need these sophisticated protocols to be in place. Now, most of these protocols that we are going to cover in this course belong to these different 5 layers of this layered structure of the internet that we will talk about, or conventionally it is called the OSI model, which has 7 layers basically. So each of these 7 layers or each of these 5 layers, they have their corresponding protocols to take care of certain issues. For example, if you want to send some message from one computer in Kharagpur to another computer in Los Angeles, right? So how the path through which it is going to be sent, how it is going to be determined, For that you have a protocol, right? So not one protocol actually. You need to have an interplay of different protocols that can help you to do it. Okay. So similarly, like two devices in the same locality, and they are maybe connected by a same wire. How they are going to communicate with one another, or if you have multiple devices sharing the same interface, same link, right? How they are going to talk to one another? Who is so because if everybody tries to talk at the same time, then you are going to have a collision of these different packets that are sent across, right? So in order to avoid collision, then you need to discipline these different nodes. So which sort of discipline you are going to bring in place? So for that you have protocols, right? So now for wired networks, you have certain protocols. For wireless networks, you have a separate set of protocols. And not only wireless networks. Actually, as I said, I work on something called Internet of Things or sensor networks. There actually you have certain more specific dedicated requirements. So due to which you need, even more sophisticated wireless protocols, which can help you to build this Internet of Things. Okay, so let's proceed further. So just I already told you. So just a brief recap of what we are going to do: organization of the course, basics of data communication, brief overview of analog and digital communication, transmission medium we are going to do. Then we are going to talk about, this is something that I have already told you. So you have only 2 machines connected directly by the link. How can you make them communicate reliably? For that, there are mechanisms of synchronization, encoding, flow control, error detection and control. Then let us say instead of 2 machines, you have more machines, right? How can you make these more machines be connected? Medium access control, addressing, etc. And then so all of these things, so I'm not going to go through because I have already done it, right? At the beginning I have told you, right? And some application layer protocols we are going to do, and some advanced topics if we find time. So let me just reiterate what are the goals of the course. So at the end of this course, my intent is that you should be able to explain how some of the everyday things that you use works underneath, right? So for example, at this time, all of us are using the Microsoft Teams to exchange these concepts of the computer networks course. At the end of the course, you will be able to understand at a gross level, you will be able to understand how this is going on. What are the important protocols that are running, right? Which algorithms are continuously running for making us talk to one another? These sort of things you will be able to understand. Of course, mind you that you will not become an expert. You will have just the sufficient knowledge to have the overall picture. You will not become an expert because this is not possible in this kind of very short duration courses. So you will also be able to appreciate how the email that you send. So you type in, let us say that xyz@gmail.com, right? And then you click the send button. Then after that, what happens? That you will be able to understand at the end of the course. Or when you type in www.google.com, so this Google web page basically opens, right? So you'll be able to understand that once you type in www.google.com, what are the things that happened so that you got the copy of the page. You will be able to understand how to make file transfers over the internet. You'll be able to understand that how in general this Google search engine basically reaches the Google server, right? So those sort of, you will not be able to understand like how Google search is done, etc. Those things are out of scope of course in any computer networks course. But once you type in www.google.com, what happens from your computer to the Google server, those things you will be able to understand. You should be able to explain the protocols that are used, the packet formats, the path, the transformation of the packets on its way. You should be able to get an idea about the design of these protocols. You should be able to identify the physical structure that makes it possible and their interconnection. With this, I stop over here. Do you have any question? Anyone? Okay. So I will tell you that somehow, actually I planned another lecture also for today because we had 2 hours. But what I see is I could cover only up to this much. So we got a little bit delayed, but eventually down the semester we'll catch up for some of these delays that are happening. And there are a lot of content, so please stay in pace, because if you fall back, if you become slow, then and once you miss one concept, the next concept you will again miss, right? So it is very important for you to stay in pace with the course. So I hope that whatever I have covered today, all of you understood. If you did not, please let me know. We still have a minute or two we can discuss. No? Okay, so if not, then let us end here. And yeah, so all the best. And I see that we have 64 participants, roughly 60, let us say. And yeah, so some of the students are not yet joined. Yeah, so all of you, please make sure that you attend all the classes for your sake. And remember that there are going to be tests, and there will be a so the evaluation is going to so we'll actually, I and Professor Gupta, we are going to synchronize how the evaluations are going to be done, but mostly it's going to be based on the tests, right? So mostly on the tests, and we'll also decide on the 20% marks, how we are going to do the 20% marks for the teachers assessment, right? Okay, so that's all for today, and good luck with the course. Next week, Monday, we also have, in addition to the theory, we have the lab. And so in the lab, actually, we will try to understand, so the little, you will be able to get the feeling of the internet. Will we'll start with something called client server programming. So how you can do the network programming, so all of these, because this is a computer science course, we'll start directly with programming, right? So you will be able to get some idea about how things work. Of course, many of these things that we will be covering over there, these are little advanced, but in the theory and in the lab, there will be a little bit of asynchrony that will be there. But because there will be asynchrony, what I have thought is that in the lab, before I give you the lab assignment to work on, which will be mostly programming based, I'm going to cover some theoretical aspects of whatever we give you, right? So don't worry about that part, because I will try to take care as much as possible. I will teach you the basics of this client server programming, and then I will give you the assignment to work on in the lab. Okay. And down the semester, actually, so we also need to do a couple of things. We'll keep you informed. For the lab, basically, there will be a mapping that will be done. Every student will be mapped with a TA, right? So we have 10 TAs in this particular course. So in the lab, basically, every student is going to be mapped with a TA. And so basically you know your first point of contact, so who to contact. Even for the theory also, is the same thing. So every student is going to be mapped with a TA, and so just feel free. Sometimes actually students are a little hesitant to reach directly the instructor, the teacher. So the TA will be your first point of contact. So do reach the TA, and whether it is technical or non-technical. And we will also do another thing sometime little later. We will also have the group formation, right? So in some lab assignments, basically grouping will be required. Groups of 2 will be formed. So basically, while somebody will be doing the client programming, somebody will be doing the server side programming, and so on. So that sort of thing, so those sort of things we'll tell you later on. Okay. And how the groups will be formed, that also will not depend on you. I will be forming the groups for you, so that you do not you do not have any kind of affinity towards your friends, right? So we will tell you, who your group member is going to be. Okay, all the best. I hope that all of you enjoy this course, and thank you. All the best. Enjoy the rest of the week. Bye bye.